Hello everyone, welcome to this meetup on reinforcement learning with its applications in Deep Razor and also we'll see some applications in AWS SageMaker. So Deep Razor is basically 1/16 scale of a self-driven car and we'll see how we can apply reinforcement learning using on Deep Razor. We have with us Suman Devnath, who is a principal developer advocate with AWS. Tony Prakaso, who is senior developer advocate with AWS, and we also have with us Nicodemus, who is a machine learning practitioner and participant of AWS Deep Razor bootcamp with JML. Also, to note, AWS reInvent is just knocking at the door 2 days from now. It's starting from November 30th, and there is a Deep Razor bootcamp happening, Deep Razor League happening at AWS reInvent. You can participate in this mini workshop, learn the skills, and definitely participate in those leagues. And trust me, I have been able to experience one of the league at reInvent live, and those are awesome. So continue with this workshop, learn the skills, and be a part of reInvent, and also Deep Razor League. Over to you, Suman. We can go with the content now.
Sure. Thank you so much, Ms. Sukanya, for organizing this, and thank you so much, Donnie, for joining in. I know it's little, at the mid time, in your date, in your time zone, and thanks so much, Nico, to sharing your time and experience. So, just to give a context about this particular session, what we are going to do is in next 2-3 hours. We are going to learn about what Deep Razor is, what reinforcement learning is, and how you can, start learning reinforcement learning using Deep Razor. So that's the whole idea about this particular session. And we will strongly encourage you to join the Deep Razor League, as Sukanya mentioned, and at the reInvent. And not only that, we are going to have a Deep Razor League after this session, which you can participate. And we would love to share some gift vouchers for the winners. Okay, so that's the whole agenda for today. And we will also look into a few of the aspects of reinforcement learning on SageMaker or on AWS in general, how you can use the reinforcement learning on SageMaker, which is our machine learning platform. And we will also touch base on OpenAI Gym, which is which has the toolkit which can build environment for our reinforcement learning problems. So we are going to see all of that as we start off. So to begin with, I would like to invite Nico. So Nico was part of the JML, the Jakarta Machine Learning Community, and he was also part of the JML Machine Learning Bootcamp, Deep Razor Bootcamp, which was organized by Donnie, and I was also part of that particular bootcamp. And he was one of those participants, and he did extremely well, in the Deep Razor League. Not only that, he will share, his learning, what he learned in last 3 months of that bootcamp. And he also built amazing blog post, which was highlighting his learning journey. So, I will hand it over to Nico, and he can share his experience with Deep Razor and the bootcamp in general. So over to you, Nico.
Okay, thank you, Sukanya and Suman, for inviting me for this event. And good morning, everyone. So my name is Nicodemus. I come from Jakarta. I work as a technical consultant, and I do some machine learning stuff. And I'm part of, I attend the session from Jakarta Machine Learning, and they make bootcamp with together with AWS about Deep Razor and reinforcement learning, and it interests me a lot because I know machine learning, but maybe some of you only know supervised and unsupervised and never touch about reinforcement learning because it's so rarely we use in day-to-day life maybe. But it's interesting because and I see Deep Razor is about to make the car, self-driving car. So I like to participate, and I participate in it. And one of the requirement is to make the blog post, and yeah, so it's helped me to learn, because when I write, it's take me more to search also about the reinforcement learning. But so when I first attend this bootcamp, I really don't know anything about the reinforcement learning. And but with the mentor from Doni and Suman, they explained it very well, and I can understand the reinforcement learning, the basic of reinforcement learning, and then they introduce about the Deep Razor, a fun way to learn the reinforcement learning. So I think it's very fun learn with the Deep Razor, because like you can see the just to, because it's in reinforcement learning, actually it has like hyperparameter, reward function, action, and so many stuff. Like, and when I start to write my blog post, I tried start begin to research, like to know the mathematics behind it, and it's very deep, and sometimes I don't understand. I still need time to learn it. But when in the Deep Razor console, okay, just to put the number, put the hyperparameter, and suddenly we can see that our car is moving and do the lap, and it's quite satisfying for me. Then, and yeah, in this bootcamp we get also the credits for learn to try the Deep Razor. And it's, yeah, at first I just do with the basic. Okay, it's 1 hour. I don't, maybe you can, yeah, it should be more mindful. But okay, I have this credit, I try, and actually it costs a lot to train the Deep Razor model. And yeah, the credit is quite a lot. But so I just try, and sometimes like I see, then okay, I'm sorry to mention, then in the bootcamp itself we have the community race. Then the pressure you can about the rain fan is like a worldwide race, but we can also make the community race. And like I see, okay, I'm just the last place and everybody is on top, and maybe I should try the, like, lengthen the training time. It will be better, but it's not a good way. But during the session, like Doni and Suman like introduce also not only the, like the basic is the basic MVP, and then policy gradient, and also like reward function, and one as helps me to build my first, not my first cut, but my, how can I win this community race, is like we have the guest from the Pro AM F1 champion Rego, and he introduced about log analysis. And using Sagemaker we can see analyze more deeply about our cars. Then at the time I learned about, like, okay, this reinforcement learning is not absolutely the model, but we also has to be more concise, and like we need a reward function, then we should define the reward function in a good way. So like maybe if you compare, like, to play a chess, and you make a model, you can make a model that can kill all the enemies pawn, but at the end you will lose because you lose your king. But maybe you can build a model that not kill so many enemies pawn, but then you win the game because you take their king. And it's all about the rewards function. So I learned about the reward function, and I see, like, my car is not run like I want. Then I dive in, like, the some example from the reward function from in the AWS blog, and then I built, like, I try the reward function, like, okay, maybe it's not good to make the car only race in the center line, but how it can be better in curve, or to stay on track, and absolutely to finish the race. And then only with that, actually only copy paste, because the AWS has all the function. and you can build more with sophisticated, but you has more deep understanding. But at the time, I don't have that much understanding, so I just copy paste, and but it's quite amazing with the result. I amazed myself also. So maybe I can share how the car race and the final model. So here's I got the 8.8 second, and so when you can have this car, like it's amazing. It's not, you don't need like so much deep understanding about mathematics, but it will be good, and I think it will be better, and we can race in another track. But for starting, it is very satisfying that see your model run and can finish the race and race complete. So to wrap up my sharing, because like I mentioned before, that we are, the requirement is to write a blog, and like it's pushed me to written an article. So I would like to share my article, and so this is my first article. I start with about the self-driving car, and continually as I go to the bootcamp, I write so my learning journey about the Markov decision process, and we will run also today in the workshop and about the, and I currently working on the policy, about to write article about the policy in reinforcement learning. So if you like, you can also see my article to learn more about the basic stuff of reinforcement learning, and I encourage you also to write your learning, because I attend like this many of the workshop like this, and I just attend, and the tomorrow I forget about what I learned. But when I do this bootcamp and I start to document it my learning, and I can revisit it, and when I do the research deeply, I can gain more understanding through the writing. So hope it can encourage you, and I wish you have a nice day during this workshop. Thank you.
Hey, thank you so much, Nico, and it was such a pleasure to have you in our show today. And thanks so much for your amazing work that you have done. And just for other people, for context, we had this workshop for roughly around 7 to 8 weeks, and in every session we just touched upon a few aspects of reinforcement learning, and Nico and many others have come up with amazing articles every week, and we are going to share all of that link while Donnie is speaking. So I'll share that in the chat for your reference. But we want we also want you to learn, and not only learn but share, because unless and until you share, you don't know which way you are going, right? And this is a great opportunity. You can reach out to the community members like Sukanya. She is an expert in machine learning, and we also have many other community members in various part of the country. So do reach out to them if you need any help, but always write something. And it's not like you should not think that okay, what is the point of writing? We already have thousands of articles, right? So those 1,000 people have not thought like you, right? That's why those articles still exist. So always feel that it's not like no one is going to get benefited with that, and if not anyone, you will be benefited with this, right? So we encourage you to write a blog post or video, whatever you feel like that would enhance your learning, as well as it will give others a platform to learn. Okay, so with that, I'll hand it over to Donnie. So Donnie is part of our developer relations team, and he is based out of Singapore, and we both work for the same team. And Donnie has been instrumental in a deep reinforcement learning and Deep Razor in particular in worldwide adoption. He's taking care of a lot of educational initiatives, Deep Razor boot camps, and with the help of Donnie, we started many sessions in India as well in last 1 year or so. So it's really a privilege to have Donnie today, in our community. And without wasting any more time, I'll hand it over to Donnie.
Thank you, Suman. Basically, it's my privilege to be here. So thank you so much, Shuman. Thank you so much, Sukanya, for having me here. And hello, everyone. I'm super excited to be here, and I'm going to talk about reinforcement learning and AWS Deep Razor. And alongside, after the end of the session, we're going to have my awesome colleague, Suman. We're going to talk about more on the implementation. So I hope all of you are doing well and staying safe. I really appreciate, despite the current situation, that all of you are still maintaining the passion to learn about machine learning. And that somehow really excites me. So let me send you an applause. Yay. Okay, so I'm super delighted to be here and share with all of you about Deep Razor. And this session is structured to help you get started with AWS Deep Razor. And by the end of this session, what I really hope is for you to have some understanding of what reinforcement learning is and how easy it is to get started with reinforcement learning to start and train your own Deep Razor model. So you can take part in one of our Deep Razor League or going out and creating your own community race. So as you know, in this session, we have a couple of speakers. We just heard from Nico about his experience on Deep Razor and the recent bootcamp program that Shuman and I roll out together. And hopefully with this session, it could help to spark out your enthusiasm to build your reinforcement learning model for Deep Razor. So before we begin, let me introduce myself. My name is Donnie Prakoso. I'm a senior developer advocate for AWS, and just like you, I'm a developer as well. I started my professional experience as a software engineer, R&D manager, and CTO for several startups. I'm specialized in microservices and event-driven architecture. And fortunately, one of my previous works involved reinforcement learning. So if you have any questions about microservices or even machine learning, feel free to drop me a message on LinkedIn and Twitter. And off from the screen and keyboard, I love to brew coffee. So if by any chance we meet in the future, please don't hesitate to invite me for coffee. There's a 99% of chance that I will automatically accept it. So this is how we structure for our session for today. We will start with talking about the origin of Deep Razor and a few components that you need to know. And then we will shift our discussion to reinforcement learning. We will cover an overview of reinforcement learning, few terms that we will use, and how reinforcement learning works in Deep Razor. We will also guide you how to build your first reinforcement learning model with Deep Razor. So we're going to have our step-by-step console walkthrough. And after you have your model, it's time for you to participate at AWS Deep Razor League or even creating your community race and inviting your friend, colleagues, or whoever you like to join. And last important piece after this session is how you can utilize reinforcement learning to unlock possibilities in real use cases. And for this, Suman will deliver another session which will talk about how you can use the notebook that he already awesomely built to practice your understanding about reinforcement learning with Amazon Sagemaker. Okay. Okay, so as a developer, one of many reasons why I love working with AWS product is that they're really putting developers as the core of their focus. And this is one primary reason why Suman and I are here today, to bring machine learning to you. AWS Mission is to take their rich experience and expertise with machine learning and put it in the hands of all developers, data scientists, and researchers. To simply put, AWS wants to simplify machine learning. They want to make it easy for all developers to easily build intelligent applications. And this is pretty much summarized on how AWS defines their machine learning services. I will not go into the detail, but I just want to iterate that these are the machine learning landscape at AWS. Each of these layers are built for every type of developers for different use cases. Now, for example, let me give you a few illustrations. So let's talk the top layer first, the AI services. if I need to create a visual analysis toolings that includes how to extract information from media like photos or videos, rather than building the model by myself, which is going to take a long time, I simply connect my application with Amazon Recognition API. And if I wanted to create a chatbot, I'll create with Amazon Lex. But for some cases, I need to go deeper and customize my models, and that's when Amazon Sagemaker, which is on the second layer in machine learning services layer, will be super useful in this situation. So the way AWS structures the machine learning services is a manifesto on how focused they really are about developers. And this is something that I really like because I will know for sure that it will make my life more easy. Oops. And talking about machine learning, we are all developers, right? And we learn by doing. And the easiest way to understand the concept, the foundation to real life implementation, is to get ourselves to hands-on learning. And AWS Deep Razor is one of few devices beside AWS Deep Lens and AWS Deep Composer that could help us to get ourselves started with machine learning. So, okay, so I just want to set the context of AWS Deep Razor. Probably one or few of you haven't heard about Deep Razor. So I've prepared a video to give you an idea of what Deep Razor is all about. So let's watch together.
Welcome to the AWS Deep Racer League 2020 presented by Accenture. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning. From the day the AWS Deep Racer League competition was announced, Accenture has been all in.
We're thrilled to be part of the Deep Racer experience.
Okay, so that's pretty exciting, isn't it? Imagine that you can build an artificial brain for navigation and plug that into a device. So, you might already have a big idea on what AWS Deep Razor is. AWS Deep Razor is a 1/18 scale robotic car, which gives you an exciting and fun way to get started with reinforcement learning by applying it to autonomous racing. So AWS launched AWS Deep Razor in 2018 to get developers hands-on with machine learning. And last year, AWS Deep Razor has enabled tens of thousands of developers globally to learn and get hands-on with reinforcement learning through the AWS Deep Razor League, which is the world's first global autonomous racing league. And AWS Deep Razor Evo is the device that you see on the screen. It's the next generation in autonomous racing, unlocking new challenges and new race formats. And AWS Deep Razor is also an integrated learning system to help developers from any level to understand reinforcement learning and how to apply it. There are 4 components in AWS Deep Razor. The first one is AWS Deep Razor Evo. AWS Deep Razor Evo expands the learning and racing with new sensors that enable it to detect objects. AWS swapping out the single camera and putting in a stereo camera and a light detection and ranging sensor, or known as LiDAR. And these sensors, they actually unlock new possibilities, which results in a new race formats that we introduced last year at reInvent 2019. So in addition of the time trial, we now have this head-to-head racing and object avoidance, which is really exciting. The second component is the 3D racing simulator that you can find in the AWS Deep Razor console. So this is something that I like to highlight, that you don't need to wait for your physical Deep Razor to start learning. You can start now in the AWS console. So the 3D simulator in the AWS console is where the building takes place. And it's really your starting point to build your machine learning skills for building machine learning models. And once that you are confident, you can then showcase during any race competition. Okay. Which is then a good segue for the next component, the AWS Deep Razor League. You can build models to get ready for racing in this year AWS Deep Razor League, or in person or virtually. And you can also build models to race against friends and colleagues using the new community race feature. So these four are the components in AWS Deep Razor. And I just want to reiterate that you can start learning right now by logging into AWS Deep Razor console, and you don't need to have your physical AWS Deep Razor device. So we need to lay our foundation first before we can start building our model. So with that, let's cover the basics of reinforcement learning. So the reinforcement learning, this is how reinforcement learning fits in the AI context. Artificial intelligence, it seeks to create machines that seem to have human intelligence, and this is the general concept. And one aspect that humans are good at is learning how to classify things or events and also make simple prediction based on past behavior. Machine learning is a subset of the artificial intelligence that aims to replicate this human ability. And machine learning also uses these statistical techniques to build models that are good at making prediction. And these techniques, these statistical techniques, learn from data to figure out what the patterns are that ultimately leads to the prediction. So machine learning has three main categories. We have supervised, we have unsupervised, and we also have reinforcement learning. With supervised learning, we can build a model to predict a value or to classify data. Models are trained using large amounts of curated training data with labels. With unsupervised learning, things are a bit different. Models are trained to identify similarities in large amounts of data to aid classification. And in unsupervised learning, the training data usually doesn't have any explicit labels like what we have in supervised learning. And with reinforcement learning, we finally can build a model to autonomously predict which decisions to make in a specific environment. And the models, they are trained in a simulated environment where the models can interact with the environment that we have defined and learn based on the outcome of actions, if an action was good or bad. So that was the quick overview for three main categories in machine learning. So let's get into a concrete example to illustrate how reinforcement learning really works. So essentially, reinforcement learning is built on an idea, like for example, when was the last time you used a reward to incentivize the right behavior of your pet? So think about our approach used to train our pet. We give cookies for good behavior and no cookies for bad behavior. It's really that simple. Now, during this training, we instruct our pet with simple actions like sit or stay or roll or fetch or even more complicated actions. And the goal of this training is actually to have our pet to do all kind of tricks, right? And that's a quick overview. I think that's a really good illustration to explain about how reinforcement learning works in a nutshell. Now, from training our pet as an example, let's dive deeper into reinforcement learning by understanding a few terminologies. To be more detailed, reinforcement learning is a machine learning technique that enables an agent to learn in an interactive real-time environment by trial and error using feedback in the form of rewards from its own action. So within the simulator, we have an agent. So this agent acts autonomously in a given environment to reach a specific goal. So in the AWS Deep Razor context, what is our agent? So the agent is the AWS Deep Razor vehicle. And what is the goal of the agent? The goal is to finish a lap around the track. Okay, so another term which is really important is the environment. The environment is the surrounding area for our agent interacts. In this case, the environment is the track that we design with AWS RoboMaker. The state is defined by the current position within the environment. So basically, this is what the agent can see through the camera. And the action can be defined with how fast or how slow the agent decides to run, and it could be also including the direction. For every state, our agent needs to take an action and achieve its goal of making a lap. In this context, it's for time trial. And depending on which action it takes, it will be given a reward. If the chosen action gets the agent closer to the goal, you can reinforce this action in the future through a positive reward, or otherwise discourage it with either a negative reward or no reward at all. And this structure of the reward is provided by the environment itself and specified through a reward function. And this reward function is actually a code written to incentivize behavior through parameters defined by the creator of the environment. And the last concept here is an episode, which represents each iteration where an agent goes from the starting position to a termination state. A termination state means if it drives off the track or finishes a lap around the track. Okay, so those are the terms that we need to know so we can fully understand the whole concept of reinforcement learning in AWS DeepRacer. Okay, so I think we get it now. It's quite obvious what these terms are in the reinforcement learning context. So in summary, that we have an agent which interacts by doing some actions within the environment, and it will be rewarded depending on how close or far from the goal. So what is the most crucial component to help us crafting the reward? And yes, this is the reward function. The reward function incentivizes the particular behavior and is at the core of the reinforcement learning. Now, to run your AWS Deep Razor card, providing the reward function will be your most important job. And let's look at this race grid to see a practical example of a reward function. So each square is a state, and the green square is the starting position, while the finish line is the goal or terminal state. And in this particular environment, the squares at the edge of the track they are the terminal state, which will tell the vehicle that it has gone off the track and failed. Now, a reward function is a function to help your agent to determine if the agent it just took was good or bad, based on the outcome of the action. To simply put, the reward function is a logic that looks at the next state of the agent is in, and based on that assigns a reward. And the reward function can be seen as the logic that will incentivize the driving behavior you want your agent to learn. And the next question is, looking at this grid race, how will you incentivize the agent to drive on the orange center line? So one way to do it is by assigning a higher reward to the center line, which makes the model will learn that actions that drive on the center line gets higher rewards than actions that leads to the sides. And initially that our agent won't have any idea of the value of landing in a state or the reward associated with an action. So it first needs to explore the environment and then explore some more in iterative fashion to build up this knowledge. And our model starts off not knowing anything about the reward for specific actions. So if we play the video, it looks like this. And then it repeatedly explores the grid until it moves out of bounds or reaches the destination before it starts again. And in this case, that our model is learning through the iteration. As it drives around, the vehicle accumulates rewards from the scores that we define. Now, beside recording each step, it is also learning what rewards the various action from a specific state leads to. And all steps from start to going off track or the finish line is called an episode. Okay. Okay, so to get the best model, the agent first needs to explore the grid to ensure it covers large rewards that can drastically change driving behavior. And this is normal, and we call it as an exploration. First, the agent needs to explore to see what rewards that can be obtained from various actions tried in the various state. For sure, it will not settle for the first best thing, as it will need to explore the environment. And as the agent gains more and more experience through the exploration and iteration, it starts learning where it repeatedly gets higher rewards. It then starts exploring less and moving on to exploiting what it has learned. And convergence happens when a model starts repeatedly picking specific actions depending on the state it is in. And as the model continues training, the actions from each state don't change anymore. Now, the model is optimizing for expected cumulative return, and model performance will be the same repeatedly, with subsequent updates to the model not really changing the model behavior. Okay, so You might, at this point, you might questioning that, but there's a trade-off between exploration and exploitation, and that's correct. There is a trade-off between exploration and exploitation, which you need to configure with the hyperparameter. If you explore too much, your model may take a very long time to converge. If you exploit too soon, your model may not find the best driving behavior and potentially also fail to converge. Okay, so now let's get back to the previous grid. Now, what we have here is a really small grid, and our agent can easily go to each square and test all actions to determine which action will result in the highest expected cumulative reward, assuming that in each subsequent square, it will choose the action with the highest expected cumulative return. Now, this mapping, where we know the value of being in a square, is called a value function. And once that we know the value of a state, it's easy for us to simply choose the action that takes the agent to the highest value. If you can map a state directly to an action, then you have a policy function, and the model is sometimes called a policy network. This idea of knowing how valuable it is to be in a state is a very important concept in reinforcement learning. The value of being in a state can be seen as the expected cumulative reward that can be achieved from the state onwards if the agent keeps following the optimal policy. Okay, so let's recap what we have discussed about reinforcement learning in AWS Deep Razor. Reinforcement learning being a form of machine learning where we are interested in creating a model that can learn how to make autonomous decisions in an environment based on the reward that it receives when it interacts within the environment. The reinforcement learning in the real world is like training your pet to behave using cookies as rewards. The reward function is the logic that incentivizes our model to learn the driving behavior we want the model to do. In the grid world, our agent first explores the environment to learn what rewards can be achieved from each state based on the various actions. And the reward function is the logic that assigns a reward based on the outcome of each action. It uses this kind of interactions to build a map of the value of being on each state. Now, the value of being in each state is the expected cumulative reward that can be achieved from that state onwards when following the optimal policy. Okay. But how does the Deep Razor agent learn? In Deep Razor, our agent is the car and it interacts with the simulated racetrack environment during the training. Okay, so this diagram shows how does the learning happen with the AWS Deep Razor. In the simulator, AWS Deep Razor drives around the track and taking pictures about 15 frames per second, and that picture is actually the agent's state. Now, for each picture, Deep Razor will take an action and end up in a new state, and this is called a step. Deep Razor Evo in particular has a stereo cameras and LiDAR sensor, so it has a more in-depth view of each state and can sense objects too. Deep Razor will collect experience, the state, action, reward, next state tuples, and all steps from that starting point until it reaches terminal state is called an episode. And once the agent has collected experience, which you need to specify in hyperparameters, it starts updating and training its model. Now, the goal during training is to figure out which action in which stage will lead to the maximum cumulative expected rewards. Now, once the model is trained, it is sent back to the agent to collect more experience. And as for the exploration and exploitation, once again, it's controlled through the model hyperparameters. Okay, but here's the twist. Unlike the grid race, the Deep Razor cannot explore all states in the simulator. It will simply take too long, if not impossible, because we have a different environment and they are so dynamic. We cannot fully determine the value of ending up in each state. And the next question will be, how do we select the action if we don't know the value of the state? So the answer is approximation. This is commonly referred to as policy optimization, which means we optimize the policy function, mapping the state to action in order to achieve our goal. Okay, so let's look at the common method of doing policy approximation using a method called vanilla gradient ascent. So vanilla policy gradient is an example of policy optimization. This is a method where we parameterize our policy function. And these parameters are simply the weights in the neural network, and the neural network represents our policy function. And essentially, this policy function takes an image as input and map the output as an action. We then optimize that policy to get the best action from each state. And the agent's goal is to get the maximum cumulative reward. So we train our model, updating the weights by trying to maximize the cumulative future reward. And in doing so, we give higher probability to the action that leads to the higher cumulative future reward. Okay, so the output is the probability of what kind of actions this agent needs to take in the specific state. Okay. And Deep Razor uses a form of policy optimization called proximal policy optimization. And this is the neural network architecture that we use in AWS Deep Razor. The default architecture is a simple 6-layer network. The first layer is an input layer, and this is followed by a 3-layer CNN to help identify the features from the images that needed to make driving decision. Right. And finally, we have 2 fully connected layers to help determine what action that this agent should take in a particular state. Now, think of this neural network as some mathematical formula, and each node in the network determines how much weight should be placed on certain features in the image. And when the weights for a certain action all become big enough, the output of the network will indicate a higher probability for the specific action. Okay, now during the training, these weights are adjusted. Weights are adjusted so the car maximizes the expected cumulative return during racing. Okay, so now we are going to the architecture of AWS Deep Razor. This is something that it's really important for you to understand as well, in case that you are getting advanced of AWS Deep Razor and you want to create a manual deep training for your Deep Razor by leveraging the Amazon's Sagemaker and also the AWS RoboMaker. So as you know that AWS Deep Razor is built on top of various AWS services. Amazon Sagemaker trains the model, AWS RoboMaker provides the simulation environment, and Amazon S3 stores the models, and all the logs that we have during the training and evaluation, they are going to be stored in Amazon CloudWatch. And when you see there's a video, later on we're going to go to the console so you can see the video. It's being delivered by Amazon Kinesis video stream. So when you start training a model in AWS Deep Razor, this is what happens. AWS Deep Razor starts an Amazon SageMaker and AWS RoboMaker container in your service account and links these two. It then passes the right parameters to start the training. The experience tuples, which is the state, action, a new state, reward, are generated inside the AWS RoboMaker. After a specified amount of experience that you define in the hyperparameters is obtained, it is sent back to the Amazon SageMaker to train the model. The new model is then sent back to the AWS RoboMaker to get more experience, and the process continues. The output models, video and metrics, they are stored in other AWS services such as Amazon S3, Amazon CloudWatch, and Amazon Kinesis video stream. Now, once that you have your model ready, you can download and plug into your Deep Razor device. And Deep Razor is powered by Intel OpenVINO to enable model optimization for fast inference on the edge. And under the hood, these are the technical specs on what's going on inside the AWS Deep Razor Evo. It runs on the Intel Atom processor with 4 GB of memory. It has built-in Wi-Fi, which we need to connect during physical event to control the car. It also has 4 megapixel camera with 360 degrees and 12 meters scanning radius LiDAR sensor. The application inside runs on top of Ubuntu OS with Intel OpenVINO Toolkit and Cross Kinetic. It has 4 USB Type-A ports, 1 USB-C port, 1 micro USB, and 1 HDMI. And with all of these ports, it makes Deep Razor pretty much configurable for future upgrades, and you can also getting into the operating system by connecting the HDMI into the monitor. So that's really cool. Another cool thing which powers the Deep Razor is actually the OpenFino toolkit. So OpenFino stands for the Open Visual Inference and Neural Network Optimization. It's actually a free toolkit released by Intel to help developers and data scientists to speed up with AI and deep learning workloads and streamline the deep learning in inference and deployments and enable easy heterogeneous execution across Intel platforms, including the accelerators. The Intel distribution of OpenFino toolkit is embedded inside the Deep Razor device. This means that you can easily take the reinforcement learning models that you've just trained and use the toolkit's model optimizer to convert and optimize your trained model. In the Deep Razor, the inference engine allows you to deploy on the Intel Atom processor. And with the standalone version of the Intel distribution of OpenFino toolkit, the inference engine allows us to deploy across multiple Intel architecture. And OpenFino is a framework, it's agnostic, so you can use the powerful optimizers or models trained to the TensorFlow, ImaxNet, or PyTorch, and then use the inference engine for high-performance inferencing. Okay, so we have covered most of the things that you need to know about Deep Razor. So let's go through the console to help you get started for building your first model. So I'm going to switch to my console. Okay, so I need to stop this first. Okay, so I think it's much easier for me if I move it to, this side. Cool. Okay, so this is the AWS Deep Razor dashboard. And as you can see that there are a few links including the video. If we go to this AWS Deep Razor console, wait up. So here you go. So there are a few videos to help you get started and participate at AWS Deep Razor League. And also make sure that you are in the US East region, and because the Deep Razor is only available in the North Virginia. And on this page, you'll see that there are a few virtual races happening with different racing formats, such as time trial. You can see that we have the object avoidance and also the head-to-head racing. And I would suggest to keep your eyes on this page as we are rolling out a new virtual league throughout the year. And especially in the festive of AWS Rainfan, I believe there are a lot of this Deep Razor virtual league that you can participate. And you can also view the current leaderboard to see the ranking position, right? So, so let's go into one of these race just to see how it looks like. So this one is the testing. So if we go to the view the result, and then we can see that we can replay the competition. So like if we click on this one, right? We have in head-to-head racing, so this is obviously on head-to-head racing, we have more than one players to race at this track. And we also have this aerial view, right? And then if we play the video, we will see what's happened within the racing. As you can see that we have two cars racing at the same time, and they are trying to get the first position, right? So yeah, so this an overview on how this the virtual league looks like. And one thing that I would like to highlight in this page is actually the community race. And this is a really cool feature that we launched at Rainfan 2019. And with this feature, you can organize your own private Deep Razor competition and invite your friends, colleague, or wider audience by sharing the link once that you have created your competition, right? And yeah, so I would suggest that you keep eye on the Deep Razor console because all of the news are happening are going to be distributed in this page so you can stay updated by visiting this link. And now let us guide you to build your first reinforcement learning model for Deep Razor. First, click on the Get Started link on the navigation menu. So as you can see the diagram, and these are the steps that you need to follow through. If you want to complete your understanding about reinforcement learning and AWS Deep Razor in particular, you can go click this button, which is the Start Learning Reinforcement Learning, which will take you to a microsite that we designed to walk you through the basic stuff. Now, this microsite is structured to equip you with all the information needed to get started. It's very well documented, and we'd like to encourage you to learn from here as a starting point. Next is next step on this page is you can start to create your model, and also you can start racing. And if you want to learn about sensors and racing formats, you can click the link on the step 3. Yeah. However, what I'd like to recommend you to build your to get started with Deep Razor is to build your vehicle first and customize it in this your garage page. So in this page, you can configure your vehicle so you have a sense of understanding on how your reward function and hyperparameters will be affected, as it's highly depend on the vehicle that you have. Okay, so let's start creating a new vehicle. Okay, so on this page, you'll be given a set of options to modify your sensors, from camera to LiDAR sensors, right? For camera, you have two options. They are single lens and also the stereo cam. Now, single lens camera has 120-degree field of view and more suitable to handle simple autonomous driving tasks such as time trial. A stereo camera has the two lenses. You can see this is the left cam and this is the right cam, and it could capture image to determine the depth of observed object. Now, the depth information from a stereo camera is valuable for the vehicle to avoid crashing into the obstacles or other vehicles in the front. So this is why stereo camera is more suitable for object avoidance and head-to-head racing. However, this two stereo cam makes training to converge more slowly compared to only using the monocam. There's also an option for you to add more sensors. Here, this is the LiDAR sensors. So this LiDAR sensor uses the rotating lasers to send out pulses of light, and the direction of and distance to the objects that a specific pulse hits are recorded as a point around the LiDAR unit. And LiDAR helps to detect the blind spots of the host vehicle to avoid collisions while the vehicle changes lanes. And by combining the LiDAR with mono or stereo cam, you enable the host vehicle to capture sufficient information to take appropriate action. But it also comes with a trade-off. The neural network must learn how to interpret the LiDAR data, and in results, the training will take longer to converge. Okay, so the bottom line is understanding the sensors for your vehicle is essential to achieve the best model performance. Let's say that you're going to take a race, the time trial race. So one configuration that you can choose is you can go with choosing the monocam, which is this option, without LiDAR sensors, right? So if you're doing the head-to-head or object avoidance, then the tasks will be more complex and you'll need a stereo camera and also the LiDAR sensors to help the vehicle choose the appropriate action. But there's no silver bullet, and you can do trial and error, tweak and tune based on your model's result. Okay, so we have covered this part. So next, we're going to talk about the action space. So we frequently mention regarding action in Deep Razor, and that kind of action is actually defined by the action space, what you see on the screen here. The action space defines which the vehicle reacts with a specific speed and steering angle. So in reinforcement learning, there are two kinds of action spaces. They are discrete and continuous action space. In Deep Razor, we use discrete action space. For a discrete action space of finite actions, the range is defined by the maximum speed and the absolute value of the maximum steering angles. Okay, so there are two components here, steering angle and also speed. Each of these two components also have granularity, and you can try to adjust each of these, like for example the granularity. See, and you can try to adjust, and then on the table below you will see the changes. Now remember that the more granular you define the action space, the longer it will be to train your model and to finally converge. And once that you are satisfied with the configuration, you can give a name to identify your vehicle during the model training, right? Okay, so we go to the next page. And now you have defined your vehicle. You can name your vehicle, and also that you can choose your vehicle color. Okay, so that's how you easily create your vehicle within your garage page. Okay, so I think it's time for us to create the model, right? And once that you have created your vehicle, the next step that you want to do is to create your own model. So we go to this page. You can actually create a model directly after you finish creating your vehicle. So there are 2 entry points on how that you can create the model, but this is how I usually do it. So you can create model by clicking this button here. Now, you can start by typing any kind of your model name. I would say that this is a testing. And then next thing that you need to do is that you need to choose the track. Now we can see that there are a few tracks that you can choose. Yeah, so actually there's a lot of tracks that you can choose. You can pick the most similar track with what you're going to race on. But remember, there's no guarantee that your model will be good. By having the most similar track, it might maximize the odds for your model to get best performance. Okay, so I'm going to choose the Rainframe 2018, which is the classic. This is the first AWS Deep Razor track when it's launched 2 years ago. Okay, so I'm going to click next here. And next you need to choose your race type. So you, as we mentioned earlier, that there are 3 kind of formats in AWS Deep Razor. We have time trial, we have object avoidance, and we have head-to-head racing. And finally, that you can choose which vehicle that you want to use for the model. So you can build like more than 1 vehicles. And the use case is usually that you want to create a few vehicles to run in a specific race. Like for example, you might want to have another vehicle to participate at the object avoidance race, or even the head-to-head racing, which is different with the time trial, right? Okay, so I'm going to choose the time trial, which is the first race format that we introduced for AWS Deep Razor, and we just click next. Okay, so so this one is where the fun begins. Reward function. So reward function in AWS Deep Razor is actually written in Python, Python 3 to be exact. And so all of these lines of codes, they are in Python. I hope this is not too small, but I can try to maximize it. Okay, so I hope it's much better now. Okay, so these are the reward function that I mentioned earlier that is written in Python. So let me share a few things to help you understand what reward function is. So a reward function is a logic for how you like to reward the agent when the vehicle moves from one position to a new position. So each time it moves, it will get another reward. And the design of the reward function should be like an incentive plan. And different incentive strategies could result in different behaviors. And a good practice is to create a reward function from a simple scenario. So you don't need to have a complicated reward function at the beginning, as you can start small and enhance it along the way. Okay, so let's now look at some examples of the reward function. So if you click on this reward function examples button, you will get a pop-up dialog for you to understand some basics. So there are follow the center line. There are the follow center line, which is the one that we are currently seeing. And then we have this time trial, stay inside the 2 borders. We have the prevent zigzag, and lastly a reward function that designed for object avoidance and head-to-head. So let's take the simple reward function, the default one, and review it. So this is the one that we're going to use for review. The first one, the follow center line. So if you have already made your decision, you can just click this button to get your functions input into the text box here, right? So this is really easy. Now this reward function helps to rewarding the agent to follow the center line, and the function leverages 2 variables, which is the track width and distance from center. Both are the parameters supplied by the environment. Now from there, it creates 3 virtual markers to identify how far away the agent from the center line. So So let me switch to the blank screen so I can explain it more thoroughly. Okay, so I hope that you can see this blank screen. Okay, so in this the first reward function, we have like for example, oops, sorry. So for example, let's say that we have, this is the track, right? So we have this is the width of the track, and the marker 1 indicates if the agent is in around 10% of the track width. So so for example, it's going to be, I'm going to write something that marks the marker number 1. So this one is this is the marker number 1. This is the marker 1, and the marker number 2, which is this side, right? It indicates if the agent is in around 25%. Oh, my drawing is really bad. So, but I hope that you understand the basic concept. So this is the 25%. So this one is the marker number 1 is 10%, and the number 2 is 25%. And lastly, if the agent is in around 50% of the track width, and this should indicate the marker number 3, right? And we need to put this is a 50% of the track width. So logically speaking, if the agent is in the marker number 1, which is around this area, then we need to give the agents more rewards compared if the agent is within the marker number 3, right? And that's what we did in the central in the reward function. We give a better reward if the agent can stay close from the center line, and they're indicated on these lines. Finally, when the agent isn't around those 3 virtual markers, we can assume that the agent is crashed, and we could give like a penalty or even a really small reward. So the reason is that why we need to give a penalty or really small reward, it will discourage the agent to do the particular actions in the future. So pretty simple, isn't it? And if we move back to the reward functions that we've shown earlier here. So these are the logics on how that you can implement that kind of strategy into the Python function. So if the distance from the centers is within the marker number 1, which is the 10% of the track width, we give them reward 1.0. And if it goes to the marker number 2, the area within the marker number 2, the reward will be slightly smaller with a 0.5. And then if it's within the marker number 3, the reward is a 0.1. Okay. And you can play with all of these parameters, and you can see that we have the list. Okay, so here are the list of the parameters that you can use within your reward functions. Everything on what you can do with the reward function is actually already well documented on the DeepRacer page. I'll make sure that I'm going to copy and paste this link into the chat box once that I've done the session. Okay, so now back to the reward function. Now, while you're building reward function, you need to remember that you're going to get what you incentivize and not what you intend. So that's why structuring the logic for the reward planning is more crucial. So, and you can see that back to our parameters, all the parameters are listed here along with the description and also the variable type. Okay. So next in our bucket list that we need to discuss is the hyperparameters. This is all the hyperparameters that you can click on this link, and then it will show you it will expand into more information that's telling you what kind of hyperparameters that you can configure for your AWS Deep Razor. The first question that probably pop your mind is, what is hyperparameters? So hyperparameters is a set of variables that affect the training process, which highly depends on which algorithm that you're going to use during the training. So as for Deep Razor, it uses PPO, or proximal policy optimization, and PPO has all these hyperparameters which is shown on the screen. So apart from the Deep Razor, if in any kind of machine learning techniques, if you want to if you go to choose one specific algorithm, you're going to use different hyperparameters on the other one. So this is what you've seen only for PPO. Okay, now understanding the hyperparameters could be daunting at first, but don't let that stop you. If you're just starting out, you can leave all of these failures with their default, and you can try to learn these along the way. And let's quickly cover a few of these hyperparameters. The gradient descent batch size. This is the first one. Yeah. So gradient descent batch size refers to the most recent random sample experience from an experience buffer and used for updating the neural network weights. Okay. So and then setting the batch size will help us to reduce high correlation from the input data. The next one is the number of epochs. Now, number of epochs refers to how many passes does it need to update the neural network weights. And the learning rate here, it controls how much the gradient descent or ascent update contributes to the network weights. You can use higher learning rate to include more gradient descent contribution for faster training, or you might want to make it lower to have a more stable model. And entropy. So we talked about exploration and exploitation before. And entropy refers to the degree of uncertainty used to determine when to add randomness. And the entropy value will diminish until your model converge. And lastly, the discount factors. The discount factor specifies how much of feature rewards contribute to the expected reward if you want to obtain a robust model training. That means that you must provide your agent more or less evenly distributed sampling from action spaces, and a balanced combination between exploration and exploitation is required. Okay, so for an example, to have a robust model, you can try to tweak and tune and combine all of these hyperparameters into your strategy. Like for example, let's say that you want to have a robust model. You will need to configure your learning rate here, your learning rate, and then entropy, and also the batch size, right? And sometimes to speed up the learning process, which that means you'll need to configure the learning rate, batch size, number of epochs, and also the discount factor. So that's how you craft reward function and tune your hyperparameters. So it really requires trial and error and also patience. Okay, so let me show you one example of the model that I've trained for 8 hours. Okay, so once that you have trained your model, this is how it's going to look like. So you can go to this page and then you can see how it performs. So I think it's not this one. I think I need to check this. Yep, take this one. So this is an example of reward graph of a model that I've trained for 8 hours. The blue and the red lines indicates the average percentage completion, and the green lines indicates the average reward. So a training job is good if the average reward and track completion is showing trends to converge. So most of the times when you see the track completion hits 100%, and if you see the average reward is on the same level, your model is likely to converge, right? So you can see that with this model, the trial result tracks shows 100% completed, and the reward function, the reward level is showing on the same level, right? If you don't see this kind of pattern, then you can try to clone by clicking this button. And with this approach, you can try to retrain your model and reconfigure your hyperparameters. And once that you have trained your model, you want to evaluate the performance of your model, right? And to do this, you can start the evaluation in the next section below the training here. And once that you've done the evaluation, you will see the result of your performance. As for our default model, it completes all laps within 30-ish seconds. So I use a really basic reward function. I use the first reward function, and then I didn't change any kind of hyperparameters, and I trained for 8 hours, and this is how it looks like, right? And then you can see that on the left side, you see that there's a there's a really interesting button. It's called download logs. So AWS Deep Razor team, they also provide a log analysis tool which you can find in the GitHub repository. Is available for public, and you can download the logs from your AWS Deep Razor console and then put it into your Jupyter notebook to perform like a further evaluation. And this is really pretty useful if you are trying to understand what's happening when the model is being trained in the background. Right? Okay, so now let's move on to the next segments, which are a few tips for building a decent Deep Razor model. Okay, so the first thing, so all of these tips is actually based on my discussion with the developers, and the first thing that you need to do is actually properly define the action spaces. So let's try to go to the action space again. Okay, so this is the action space page. So as we know that the action spaces is quite flexible for us to define, and that could be an advantage if we know what we are doing, or could be a problem if we don't. So there are two things that you need to consider. Either you keep all the actions listed on the action spaces here and use it within your reward function efficiently, or you just remove those action spaces that you don't need. Okay, now still on the action spaces, different tracks, they have different curves, and the action spaces defines two things, which is the steering, yeah, and then the speed. Right. Speed isn't that much needed in most tracks, but most of the tracks have curves, and you need to define different angle to steer your cars. So before you define your action spaces, it's much better to know exactly what is the steering angle for each track, right? Okay, so let's switch to the track. I think I have it open somewhere on this one. Oh yeah, so here's the track. Here I have an image of Deep Razor 2018 Championship track. And as you know, in the reward function, you can utilize all of the available parameters. And one thing that I like to emphasize is the waypoints. So this is the waypoints. Here you go. So waypoints is the list of coordinates along the track center. It describes all the coordinates within a track that your agent can follow, right? So it so if we go to the screen to the track, the waypoints is going to be look like probably like a simple dot here, right? So this is 1.1, this is the second waypoint, this is the third waypoint, right? Now, so that's how the waypoint looks like. It shows you the coordinates. It has actually the list of index that you can use to get a pinpoint for the coordinates of all the tracks. And different tracks, they have different waypoints. Now, but remember this, these waypoints alone will not be useful for you. But what you need to is to combine this parameter with the closest waypoints variable, which you can show, you can see it here. Yeah, the closest waypoints here, and also the closest objects. The closest waypoints is needed and is really useful if you are running for the time trial race. And for the closest objects, is much more useful to give you the coordinates whenever that you participating in head-to-head racing or in the object avoidance, right? And both of these parameters return the index of the closest waypoints, right? So remember this, these parameters returns the index of the closest waypoint, right? So sometimes it could be like what's happening in front of you or behind of you. And you can look up by setting the index of the waypoints. Now with that, you can see what the next coordinate for your agents to follow. Now this technique is particularly useful if you're building a reward function to follow a specific racing line, right? So if we go back to the to our track here, so we can have this waypoint here, and then let's so let's imagine that we have this car over here, right? the cars is represented as a rectangle, and the waypoints is represented as the circle. Okay, so in the case of the waypoint and the closest waypoint or the closest objects is going to give you the index of this one. Right, and then when you use this kind of variable, it will give you an index. And then the next question is that what should I do with this index? So this is something that I mentioned earlier, that you can use it for the waypoint. So this is the waypoints. This is a waypoints variable, which actually this is a list of index that you can use, like probably 0, 1, 2, 3, and then you can use this index to get what is the coordinates of the closest object or the closest waypoints by setting this index to the waypoints list. Okay, so that's how you use the waypoints and also the index, and also those two variables, closest objects and also the closest waypoints. Okay, so the next tip that I want to share with you is what I got from Raygo. So Raygo, or Ray G, is the winner from the Deep Razor F1 Pro Am event. And one of his main tactics is to compute the optimal racing line. So the objective of the optimal racing line is to decrease the turnaround time for a car to complete a lap by leading the car to cut curves and decreasing the overall track length. So, and different tracks, they have different optimal racing line. And so the idea is really simple, is that you need to learn all those curves and you need to get the optimal racing line. For example, you can see that there's so there's a curve over here, right? So this is the curve, and then this is the curve. So what this optimal racing line, what it looks like, is that probably that because it has like a third curve, you can go like you can make your car or agents to go from here and just to cut the diagonally the track, and then from here it can go from here to this side. So different tracks, they have a different optimal racing line. So by using the waypoints and then the closest object or the closest waypoints, that means that you can have like the optimal racing line. And to help you get started, there's a theory called K1999 path optimization algorithm. So you might want to check that out first. And so this is something that we can do. This is the 2018 championship track, and if we look at the track here, what we can do is just we can do for each curve is to cut down the path, and by iteratively doing this for every curve in a track, you will get your optimal racing line. Right now, about the reward function. Back to the reward function. Reward function is the heart of Deep Razor because everything else already been taken care for you. So there are a few tips that I can share with you. Okay, so first is that you need to be really careful about the distance of the car to the racing line. Let's open the parameters here. Okay, so you can use, if you haven't configured your racing line, you can use the distance from center as well. So the idea is that you can give more rewards if the car is within the width of your racing line, and punish the car if it goes outside of the racing line. Right. And the next tip is the moving fast through the center line. So I hope that you still remember the waypoint that we've discussed earlier, right? So we just discussed it. And now in this case, like for example, that if you want your agent to finish the lap much faster, is that if your agent detects, let me put some agent here. So this rectangle illustrates the agent. So if the agent detects that the track that it's on the state and in the couple of the feature states, if it sees like it's like a direct line, right? Then you probably want to adjust the speed. So let's do it again. This is our car, and this is the track. You can try to adjust the speed so it can go straight to the center line. You might want to and you might want to increase the speed here, so that way that your agent will finish the easy part of the track, right? And lastly, structuring the rewards and penalties. I think it's a good idea to give a significant positive rewards if your car finishes the lap in few steps, and give a big penalties if it went for a wrong decision, such as goes off the track. So if you go here, then you can see that we have this variable called steps, right? And then you can see that you can combine this variable with the progress, which is the percentage of track completed. Right? So you can see that one thing that you really need to really put your focus on whenever that you are building the Deep Razor model is not solely on the hyperparameters. And some of you might want to tweak out the hyperparameters, but here's my advice. Start by defining the reward function first. Once that you have settled with the reward function, you can tweak the hyperparameters. And all of those hyperparameters in Deep Razor actually already in optimal configuration. So you don't need to focus on that part if you're just getting started. And you need to focus on more on the reward function. Okay? Okay, so I think that's all the tips from me. I hope this is helpful for you. So let's switch back to the presentation. Okay, so this is the presentation. Let me start it again. Okay, so at this point, you can build your own AWS Deep Razor model and even tweak and tune your hyperparameters if you want to get your best model performance. And if you are already at this stage, you are ready to participate at AWS Deep Razor League. And let me share you a few things that you need to know about Deep Razor League. So launched in March 2019, the AWS Deep Razor League had tens of thousands of developers race in person and online to see who takes home the championship cup. So there are two ways to race. First is a physical race at AWS summits, and the other one is to race on virtual circuit. And at this current situations, that more of the races went for the virtual circuit. Now, virtual circuit happens throughout the year, so watch out for the new race release on the Deep Razor console. And with the EVO's new stereo cams and LiDAR sensors, it enables 2 new racing formats in addition to time trial racing. In time trial, you will race against the clock in a single car on track race to see who gets the fastest lap. In the object avoidance format, you'll have a time trial race, but with the added challenge of navigating tricky objects. And lastly, that in head-to-head racing, you will race your model directly on the track against another model to see who crosses the finish line first. And for the virtual circuit, you have seen on the page that thousands of races race in 8 virtual race months with time trial, object avoidance, and head-to-head divisions, right? So, and the virtual racing community is continuously pushing new boundaries. From hyperparameters tuning reward, function crafting, and all the way to creating their own virtual tracks. Okay. And don't forget, here are additional resources for you to learn more about AWS Deep Razor. And I just want to give a big shout out to Deep Razor Slack community, which you can join at join.deeprazor.io. You'll find yourself a vibrant and helpful community if you want to learn with fellow developers across the world. Yeah, so I think this is one really good resource that you might want to take a screenshot. If not, try to make sure that I'm going to copy and paste into the chat box once that I finish the session. Okay, so as most of you already know, AWS reInvent, the biggest AWS Learning Conference event, is happening in 2 days. And Deep Razor is one of the highlights. So if you haven't registered, I really encourage you to do so, as you will get lots of useful sessions to build up your cloud development skills for free. And for Deep Razor, we have sessions for different level, either you are getting started on advanced developers, right? So we have on the bottom side, you can see that we have 3 sessions type. We have Get Rolling with Machine Learning on AWS Deep Razor, which is intended for beginner and intermediate. And the next level is to shift your machine learning model with Overdrive with AWS Deep Razor analysis tools, which is intended for intermediate developers. And also for the advanced developers, you can join to replicate in this session, which is titled Replicate AWS Deep Razor Architecture to Conquer the Track with Sagemaker. Oh, I just love the session. To conquer the track with Sagemaker. So you're going to do like a manual provisioning with Amazon Sagemaker. So So yeah, so all these 3 sessions are really structured for developers with any kind of level. So I really encourage you to join at least one of the session. If you're just getting started, I really recommend you to join the Get Rolling with Machine Learning on AWS Deep Razor, right? And to get started with Rainfan, please visit the link as it shows on your screen, as it will guide you to different web links and provide more information along for the registration link as well. Okay, so that's all for today. Hopefully the session helps you to understand how reinforcement learning works and how to get started with AWS Deep Razor. Okay, so with this, I'm going to pass the mic to you, Suman. And once again, thank you, everyone. I'm Donny, and see you on the track.
Thank you so much, Donny, for such a wonderful, session on Deep Razor and reinforcement learning. And I'm very sure that we will be seeing a lot of participants who will be participating in our Deep Razor League, which we are going to share now. And I would strongly encourage, as just Donny mentioned, we are going to have Deep Razor League for the reInvent, and there are different tracks, a lot of tracks that are coming up, and we will share that link. I think you can go to the console of AWS and just go search for Deep Razor, and you can land there. So looking forward to see you there. And on top of it, I just shared Nico's blog. I guess that you should read a few of his blog. It's wonderfully written, and just keep that in mind. When he started, he did not know much about Deep Razor and all of that, and this is his learning that he has put in in words to share with everyone. So it's quite encouraging. So feel free to go over them. So with that, we'll go to the last section for today, which is on how reinforcement learning works with Sagemaker, and we'll also touch base on some other platforms which Johnny has touched upon during his session. So give me a second. Let me share my screen first. Okay, so I hope the screen is visible to you, and we are just going to. I'll just put my slides on presentation mode. So we are not going to have too much of content now, but we just want to give you an intuition of feeling of how the Sagemaker works for reinforcement learning in general, and we'll also see what Sagemaker is about. So as I just mentioned, I'm very sure that you have a good time. I know that it's a weekend, and during this pandemic, there are a lot of commitments that you have on your personal side, but we really hope that you have learned something in last 1 hour or so, because I really don't feel good that you people just join and they don't learn anything, right? So it's better not to join rather than just wasting their time. So from here on, what we are going to see is how you can make use of Sagemaker. So Sagemaker is one of the platforms that we have for machine learning, for data scientists, or for software engineers in general, where you can train your model, build your model, and deploy your model, and do everything, right? And we at Amazon or at AWS, we give you all the tools, all the frameworks built in, so that you don't have to worry about the different frameworks, platform, scale. That is the most important thing, because as you grow, as your company grows or your application grows in terms of user base, your application need to scale. And so by scaling, we mean that the infrastructure supporting your application should also grow. So you don't have to worry about all of that with Sagemaker. So this is a very old slide where we just say that how we divided our machine learning services, right? We have the AI-based services, which is on the top layer, which is API-based, where you don't have to train any model. You can just send an API to get the prediction, right? So it's like if you want to integrate any AI-based service into your application, you should get started with the AI services like recognition for any image-related or vision-related task, like if you want to detect an object in an image, or like a number plate in an image and stuff like that. So that's the AI-based services. And then at the very bottom, we have the machine learning framework and infrastructure, where we just give you the adequate resources in terms of GPU, CPU, and compute. So basically, we just if you know inside out about all the nuts and bolts about machine learning and deep learning in particular, you just need a very high powerful system or a virtual machine, you should check the deep learning framework and infrastructure layer, where you can create an EC2 instance, which is a virtual machine service from AWS, and you can select how much CPU, GPU you want, and all of these instances or machines come with preloaded frameworks, right? So you don't have to install PyTorch, MXNet, and all of that, right? Everything is there. You just have to spin up the virtual machine and get started with it. So it's very, very easy in terms of having that infrastructure with you. But we are going to focus on Sagemaker because that is the bread and butter for any software developer who are developing something on AWS. So it's one level above the infrastructure layer, where you don't have to manage the EC2 instances or machines and all of that, but you can do a lot of things with Sagemaker, right? And we are going to see a few of them. So if you look at the whole machine learning process, we have to, this is not related to reinforcement learning, but for any machine learning problem in general, we spend a lot of time in collecting and cleaning the data, because that is the most important thing that we all machine learning engineers do, right? Rather than spending most of their time in training and deployment. So that is still a very hard part, in the machine learning pipeline. And then we have to develop, come up with a model, train that model, and finally we have to deploy. So it's still quite complicated. And this is where Sagemaker comes in, where we have different features within Sagemaker, which can help you to do all of these, cater all of these problems, right? So we have ground truth. If you have a data, but it is not labeled, and you want to train something with that data, but you need to have that data labeled. Or if you do, even if you don't have data, we can help you with that. So we can use ground truth for this. And then the main thing where you have to write code to, for your algorithm, or you have to train the model, we give you a Jupyter Notebook platform, which is, Sagemaker Notebook, we call it, which is quite similar to Jupyter Notebook, but there are a few, advancement that is there, and we are going to see that in the demo. And you can use that platform for training and inference as well, and we are going to see that in a few minutes from now. So this is how the Jupyter Notebook looks like. It's quite similar to what you would have seen when you install Notebook, a Jupyter Notebook in your laptop or any server. But the only difference would be, one of the few difference would be, you can integrate that with your GitHub. You can pick any of these kernels. So you don't have to install any of these kernels, PyTorch, MXNet, Chainer, all these frameworks will be preloaded. So you just have to create a Jupyter Sagemaker Notebook instance and get started with your notebook. So you don't have to worry about all of these frameworks. It's all preloaded. You just have to write code, right? So you don't have to spend time on auxiliary things. And the way that training works in Sagemaker is there are different ways that you can do the training, and whatever I'm saying, I have not yet come till the reinforcement learning part. I just want to show you what is the what is the value add with Sagemaker if you want to do any machine learning task on AWS, right? So the way that Sagemaker works is this is just one part of it. You create a Jupyter Notebook, or you create a Sagemaker Notebook instance on AWS on Sagemaker, and after that you get you just create a notebook like this, right? What you see on the screen. But now let's say that notebook is will be hosted in somewhere, right? It is actually hosted in one of the EC2 machine in AWS, which is not in your VPC, but Basically, it's there somewhere in the cloud, but that is not that powerful, right? And we want to do some training. Now, for your training, you need a very high intensive system. So the way that Sagemaker works is you can use the Sagemaker SDK, and you can use this estimator class or estimator object, which will take the algorithm or the your code, or you can use the built-in algorithm from Sagemaker, and it can create a container for you where the training will happen. And that container will be hosted on a system which you define. So if you see here, we have defined that the system that we want the training to happen should be MLC4 X large. So this is a one of the type of instance which has high amount of CPU and memory. So you can define whatever instance you want, and you can also say how many instances you want this training to happen on. So here we have mentioned just one. That means the training will happen in only one instance. So let's say you have a very big chunk of data, and you know that training should happen distributedly in multiple instances. You can always say the training instance count as let's say 10 or 50, whatever. So Sagemaker will take care of distributing that data, your training data, to all the instances and do the training in parallel. Right. So this is how the whole thing works. It's just few lines of code, and the main part here is that container, right? So this is the container which contains your algorithm. So that container might be your own custom-made, container which has your own custom code with different algorithms, but it can be the built-in algorithms as well. So it could be, let's say, reinforcement learning algorithm that we have. We have our own implementation. It could be an image classifier. It could be an object detection classifier, or it could be maybe object segmentation. So it can be anything, right? It can be linear learner and all of that. So you get the idea. So it should be one of the container which has that algorithm. So in this case, we have just taken an example of linear learner, let's say. All right, so this is the container, and this container is actually hosted in our ECR repository. You can think of it as a ECR, as a repository where you save all your container images. So the moment you call this, you write this code estimator, and then you give the container name. What AWS does, or what Sagemaker does, is it pulls that image from the ECR repository, and it creates a container on this instance, whatever you mentioned. So like here, you have mentioned it should be M1C4X large. So it will pull that container image, and it will create a container on this instance, right? And this instance will be used for the training. So you are running this code, the whole code you're running from your notebook, right, on Sagemaker. But the training is happening in somewhere else, and which is that place? It is this instance, what you define here, right? And you can also set the hyperparameters, as Donnie mentioned. These are the parameters that you can set before the training starts, and it's an external parameter which can control the training, and you can play around different parameters, and different algorithms have different hyperparameters, according to that algorithm, what algorithm you are using, and you can train and see, how it is performing in terms of different matrices, right? So these are the different algorithms that we have built in, like XGBoost, PCA for clustering or dimension reduction, DeepAR, blazing test, image classification, object detection, and so on and so forth, right? So this is the whole idea. So this is what we mentioned. We just discussed. Let's say this is your, your system, right? Let's say your laptop, and you just log into say AWS, and you opened your Jupyter notebook, and in this notebook you have written that code which you have just seen in the previous slide. And the moment you start the training, it creates an instance, and it pulls that image from ECR, and it runs the training job. And once the training is done, you can similarly deploy that model in some other instance for inference, right? But the point to make is, to consider here is, let's say your training job runs for 10 minutes. This instance will run only for that 10 minutes time. and you will be billed only for that 10 minutes, right? So it's not like you have to have a very huge virtual machine with lots of GPUs and CPUs, and you have to keep it dedicated for your training job, even if the training is done, right? Or even if the training is over, you don't have to pay for it, right? So it's just like how much training time that it took, you will be charged only for that, right? So when we talk about reinforcement learning on Sagemaker, this is the image that we get from the documentation. So we'll just go to the hands-on to get a more understanding on a few of these things. But you can select any of these frameworks like TensorFlow, MXNet, PyTorch, Chain. These are different frameworks that we have, and the framework that we have used to build our Deep Razor is TensorFlow. But you can use any of these frameworks, and we are going to see one example for that today. And on top of it, you can have you need to have some platform, all right? So some tool or some environment where you will be doing the training, right? Just like for the Deep Razor, we have used RoboMaker as an environment, right? The virtual environment. Similarly, there are many various platforms available, like OpenAI Gym is one of them, and we are going to see that in a moment. So we do support all of that, and you can make use of this. And you can also use the Intel's RL Coach, algorithm framework with different algorithms like PPO, DeepQN, and all of that, right? So all of these are inbuilt. It's there on Sagemaker RL, so you just have to make use of it, right? So with this, I guess it's pretty dry unless and until we see this. So let me just switch on to. Okay, so before we get into Sagemaker, what I want to show you is how you can make use of OpenAI Gym, right? So OpenAI, so if you search OpenAI, so this is the OpenAI Gym, and it contains the toolkit, for different environments. So like we have environments like Cardbowl. This is one of the environments which you can use to make a Cardbowl game using reinforcement learning. Similarly, we have different games like Frozen Lake and all of that, right? So you should visit their website, and if you click on this environment, you will see all different kinds of environment, right? And we are going to play with one of these environment now, but this is the website that you should use to check for any environment for any of your problems, right? So I am on my laptop. Okay, so this, I have just opened up my Jupyter notebook. It's running now. So I just go here, and this is my Jupyter notebook. So now, since this is in my laptop, I don't see any other kernel. But once we create an instance on Sagemaker later on, you will see that you'll have all those different kernels. Okay, so let's go to the second notebook, reinforcement learning algorithm. I have already opened it. Okay, so this is the summary of what, I mean, I'll share this code with you. You can have a look, right? So it's nothing much fancy, but the whole idea, what Donnie mentioned, for when he was discussing about reinforcement learning, is we need to figure out the policy algorithm, right? Which is the right policy. So what do we mean by policy? Policy is basically, you need to know which action to take, which will fetch you the maximum reward, right? That's the whole crux of reinforcement learning. So you need to come up with an algorithm, right? So there are different ways that you can come up with those policy search algorithm. So there is a brute force method where if your problem is in small dimension or small search space, you let's say, if I give you an example, let's say you have a block, okay, let's say a maze, right? And in that maze, there are few blocks where you have the obstacle, and you start from one point and you have to reach a goal. And that whole maze is, let's say, 10 by 10. So the maximum number of states would be 10 into 10, right? 100 states, right? So you can always come up with different possibilities to go from start to that end state, right? And you can create a hash and you can save it. So that is kind of a brute force where you compute all the possible actions or states, and you come up with a hash. And when the algorithm starts, you just pick the best action given a particular state, right? So let's say you are into a block number 5. From block number 5, where you should go, block number 6 or block number 10 or block number 11. So if you use brute force, it will have all the states information, right? Like which state or which action should I take to enhance my reward. So that is possible for only small scale problem, which is not very practical, but this is kind of a brute force. So for most of the algorithms, we have a brute force method, right? Not only reinforcement learning. And there is another technique called a polyfic gradient method, which is used in our Deep Razor, and this is one of the mostly used, commonly used method. So in this case, you don't have to worry about the Markov decision process, which Nico has briefly touched upon, and you can read about it in his blog, which I have shared. So, but in policy gradient method, you are given a present state, and there will be a neural network or CNN, and it will compute some prediction. So it will give you some actions, some action that need to be taken. All right. So it doesn't have to go over the Markov decision process and all of that, right? So, but it's a little complex because you don't know in any neural network like what is happening in the middle, right? You can visualize that, but the control is not over you. So it uses gradient ascent, algorithm when it back propagates and updates a weight. So if you are into deep learning, you know that there is something called a gradient descent, which reduces the loss while it back propagates. But since here we need to improve the reward, like we have to increase the reward, we use gradient ascent. It's just the opposite way to look at it. Okay. And then we have a value function method, which is based on Markov decision process. So let's quickly go over, a quick example how this OpenAI gym works, right? So you need to first install a gym, which you can install it. You can go to this website and you can go to the GitHub page and download it, or you can just do pip install gym. And once that is installed, right, you can import gym like this, and then what you can do is you can create an environment. So this is just in a screenshot. I just thought to show you what problem we are going to solve. So we are trying to solve this problem of cart pole. So this is a cart and there is a pole, and it will move. So we have played this game, in our childhood days, right? So I mean, considering my age, so I'm quite old now. But basically, we need to come up with a reinforcement learning algorithm or reinforcement learning approach to solve this problem, so that the pole doesn't fall and it can move around for a longer period of time. Okay. So now for this problem, we need to have an environment, right? So we don't have to write the code to build that environment. So we can use a gym, and a gym has a cart pole environment. So if you want to have a different environment, like here, if you go to this environment, there are different environments, right? A cart pole, a mountain car, and all of that. So whatever environment you want, you can just mention it here, and it will create an environment for you, right? And once you have that, instance of that environment, you can have the observation space, you can get the action space, you can also get the reward threshold, right? So important part is these two. So for this particular problem, the action space, you might have guessed it, it's pretty simple, right? The pole or the cart can either move forward or it can move backward, right? These are the two actions at any point in time this cart can take, right? So that's why the action space that it has is discrete, and it is 2. Okay, and then the observation space is how you define a state of this particular cart pole at any point in time. Just like in Deep Razor, when Donnie was sharing, he mentioned that at any point in time it takes images, right? So the camera in that Deep Razor, it takes images, and we have 32 frames per second, and it takes all those images and it sends it, right? And those images are nothing but the at the present state what that Deep Razor car is looking at, right? And based on that, it has to come up with some action that where that card should move. So similarly, in this case, the action space is defined by the observation state is defined by these four quantities: the cart position, cart velocity, pole angle, and pole velocity at the tip. Right? Why pole velocity at the tip? Because this is what it is moving, right? It's not the pole velocity at the top. It doesn't make any sense, right? So these are the four inputs that any state will have, right? And this four inputs will go through some neural network. And why neural network? Because we are using a policy ascent algorithm, policy gradient method, right? Using gradient ascent algorithm. So we are going to use this. That's why we are going to have some neural network here. What is that neural network? We don't know. We have to build it now. But after that, given a state, it will predict two things. Either it should go front or it should go backwards, right? These are the two states that it can have. And this training or this process continues. And it learns over the period of time what action to take, right? Based on these four values. Now we are done with the environment. Now the next thing is we have to build this network, right, which can create these predictions. Now we are going to use a very simple neural network using PyTorch, but it can be MXNet or whatever, right? So it will take the input layer inputs like these four quantities: cart position, velocity, angle, and velocity at tip. And then we are going to use ReLU as an activation function. So if you are new to CNN or deep learning, so ReLU is basically a function or activation function which adds non-linearity, right? So if you, and the way that ReLU works is if you, so I'll show you that ReLU. That's the, so if you look at ReLU, it's like this. So ReLU is just a function. You can think of it as a function fx, and the moment you give an x, it will return x if x is greater than 0, and if it is less than 0, then it just returns 0. So that's all. So ReLU is a fancy name, but basically it just bypasses the positive numbers and just discards the negative number. That's all it is. Okay, so we are going to use ReLU, and then we are going to have a hidden layer or the output layer. This is not the hidden layer. This is the output layer, and in the output layer we should have two outputs, right? So we will be having the outputs here, and then we are going to use softmax because we need to have the probability of going front or backward, right? So this is going to be, so let me just mention this. So this is going to be our hidden layer. Okay. And we are going to have the softmax. So towards the end, at the end, this is our output. Okay. So output can be front or back, and we use softmax because it just puts a value in between 0 and 1. It will return an array of two numbers, and because first number will define that, let's say it should move front, and second number will say it should go backward. So if the network feels that it should go forward, maybe the first number will be quite high, so maybe 0.9, and the second number would be 0.1. But when you sum that, it should be 1. So now we have the model, we have the environment, everything is done. Now we have to start the training, right? So this is just a for loop, and we just calculate the loss, and we just keep on doing it for a certain number of time, right? So here we are running it for 500 times, and we don't have to. I mean, you can go over this, but it's simply we are just mocking it. So we are using the current state, and we are taking a random choice. So we are just randomly picking some state, and we are just feeding that to the model and trying to see what action we should take. Okay, and that's how we just keep on running. right? And after 500 trajectories, so trajectories is nothing but a collection of state, action, reward, and again state, action, reward, and this cycle goes on, right? You come to a state, you take some action, and based on that action, you get some reward. Again, you come to the new state and you take some action and you get a new reward. So when you continue this, over the period of time, we call this as a trajectory. And this continues till we have some horizon. And these are the terms that are used in the reinforcement learning. And horizon is the last point. Beyond that, you don't care, right? So you just, because when we talk about reinforcement learning, we cannot foresee things. We just see things as it comes, right? So we can predict we can take a decision based on some some intuition, but we cannot do. We do not know, how it is going to behave, in future, right? We just know the present state. So now, when you look at how the cart pole or the trajectory duration is, you will see that initially it was not able to move that much, and it was the duration of the trajectory was less, right? Because it was not trying to it did not learn that well, right? But over the period of time, it will know that when to move forward, when to go backward, and you see that the duration that the cart pole is in the stable state is more, right? So you see that the curve will go little up. Now, when you look at it, let me run this and see that how our training got executed. So if you see here, in the left hand side or in the bottom, the same thing, and you see that how this got trained, and it could able to get a stable state, right? So this is how you use OpenAI Gym or to build any network for reinforcement learning. But in this particular small toy example, what we have done is we build this whole thing, right? Although this is a small neural network, but we have to write this code, and we have to write this training loop, and we have to calculate the loss and all of this, right? So which is not very easy for complex problem, right? And that's where Sagemaker comes in. Now, when you go to Sagemaker has a built-in implementation of reinforcement learning algorithm, and you can make use of that, right? So now let's go to Sagemaker, and if we come in the home page, you can search for Sagemaker. Okay, so you should not search for Sagemaker RL because RL is a part of Sagemaker implementation. So you can come to Sagemaker, and you can come to notebook instance. I already have lots of notebook, but just to quickly show you how you can create a notebook, you can click on notebook, and you can give some name, demo 1, 2, 3, whatever it is. You can click on the type of instance that you want. Okay, and let's keep it default, and you can just click on create notebook. That's all, right? If I just click on this, it will create a notebook for me, which would be in pending state. But once this is done, I should be able to get some tab here, like open in Jupyter, things like that, what you see here, right? So we are going to open another instance of this, which I have created. So this is my instance for notebook. So I can just click on this, but I've already opened it in another tab. So this is running on that Jupyter Sagemaker notebook instance. Okay, so now if you see in the new, you have all these kernels. I have not installed any of these, but it's already there, right? So it gets updated, based on the latest stable release. And another thing I want to show you is you also get an option of Sagemaker example, where you can come and select all the algorithms and implementation and sample notebooks, which you can preview them or you can use it. The moment you click on use, it will get copied into your notebook, and you can start working on it. Okay, so these are this is something that you should explore. All right, so now in this problem, what we are going to do is in this particular example is this is a complex problem, a relatively complex problem, and this is about predictive auto scaling. So this is one of the features that we have introduced, I guess, in 2018 with EC2 instances, where you don't have to scale your application, and you don't have to define how many instances AWS should add when the workload increases. So it can automatically predict by looking at the workload, and it can add instances, on the fly, or shut down instances on the fly if no one is using it, or there is not enough workload. And this is based on reinforcement learning, right? So this is just a toy example of that, or just a small implementation of that. It's not the exact implementation, just to give you an intuition how you can use reinforcement learning to solve a problem as complex as auto scaling, right? So in this case, again, we need to have an environment, we need to have an agent, and we need to have a script which can train that. So we are going to use a script, and this script is already there, called AutoScale Sim, and this is also based on OpenAI Gym. So the reason that it is based on OpenAI Gym, and why we need to be compliant with that, because generally people use OpenAI for any implementation of reinforcement learning. So when you use them, you need to you will always search for these methods, right? Observation space, action space, and reset the environment and all of that. So this particular script is based on OpenAI Gym. That means you will have all those methods, like resetting the environment and going to the next state and all of that in this. Right? And we need to have a agent, which agent is nothing but the algorithm. In the previous example, we have wrote that neural network, but now we are going to use RL Toolkit, from Intel Coach, right? So this is something that that Intel has developed in their AI lab, and this is the page for that in GitHub. So you can just search for Intel Labs Coach. You will get that. You can go through the source code as well. But here, we are not going to write the RL algorithm. We are going to use that, which is there with Sagemaker, right? And we will have a training script, which will just go over the training part. Now, one thing is, since we are doing it for a demo, and when the problem is auto scaling, we need to have power on, power off machines based on some real workload, but we don't have real workload. So we need to have some mechanism to fake that workload, right? So that's why this script have that workload defined, so which can, which will stimulate some workload for instances, right? So if you just come down, and if you see that, so this is the workload. If you see, this is the workload. Okay, so like the load is coming down, and it's going up, and then there are some peaks, right? And in this case, unlike Deep Razor, what we have seen, right, where the agent moves over the period of time, here agent doesn't move, right? The agent is the algorithm or the code, and it just gets new data at every point that about the workload. And based on that, the agent should take a decision whether you need to shut down some instances, or it need to add some instances, or it might decide to do both, right? Shut down some instances as well as create some instances. So in this problem, the agent is the code, right? And the data that is coming is based on the timestamp, right? So every timestamp, it gets the data that, okay, what is the workload? How is the workload looks like? So this is the stimulation of the workload that the scripts creates, okay? But you have to keep that in mind, that the algorithm, the reinforcement learning algorithm, can see the workload at any one point in time. It is not going to see the whole workload like this, and then it can predict for future. That would become a supervised learning approach, right? But here it will just get one instance, at every point. It will just check the, it will just get the workload, and based on that, it has to take some decision. But we are just plotting this because we are stimulating this workload, and just want to see that how that workload looks like. Okay, so now if we go up, this is the script. this is the script, and it also have these methods: init, step, reset, and these are the methods which are there in OpenAI Gym implementation for any of their environment like Cartpool or Frozen Lake, etc., etc. So we need to we also have all those implemented in this script. So when you call initiate, it will instantiate an environment with some predefined state, and then you can call this method called step, where it will take some action in that environment. Now there are a few methods which we can briefly explain. Okay, so in this case, if you see this step, it checks how many instances it need to turn on or it need to turn off, right? That is what in this particular step is happening. And before it checks the load again, it waits for some time. That's why there is some warm-up time, right? So it just waits for that system to come up, and after that, it again checks the current workload. Right, and once it gets the current workload, it tries to get some reward. Right, so if you now go to the react to load function that's here, if you see that, it will check the current load and it will try to see that if the current load is less than what is anticipated, then you will get some reward. Right, so that means that you have taken a good decision by adding an instance, and now the workload has come down. But if you have taken some wrong decision, then you will not get any reward. So you will not get any reward means you will get a negative reward, right? So that's why you get a negative reward. So that this cycle goes on, and once it gets a reward, what this every step returns, this method returns, is it will return the next observation or the next state along with the reward that it has accumulated, right? So, and this cycle keeps on going, and this is what this step is. So if you remember this in Deep Razor, when Donnie was explaining, right, that there is a action space where the car can move 30-degree left, 30-degree right, and all of that. And these are from the action space. The car need to move, and every step. So every small box in that animation was one single state, right? And it has to move one step at a time. And this is what this step function is, in this particular problem. So now that we have our workload stimulated using the script, and also we know that how to stimulate this environment, the next thing would be to run that algorithm. And what is that algorithm? It's based on the Intel RL coach algorithm, right? So, and this is the script for that. So this is a very standard, PPO, clipped PPO algorithm, and this is the same algorithm which are used in multiple problems with different hyperparameters, which you can always tune externally. But this is the main algorithm. So we are not writing this algorithm. We are just using this algorithm, right? So, and it has all those parameters which you can tune as well. Okay, like learning rate, or maybe the batch size, and what should be the optimizer that it should use. So it uses Adam optimizer, but you can always change that. So we have many other optimizers, right? Adam, RMS prop, and all of that. So you can always use any of this. And finally, you just have a wrapper code, which is a training coach, which just loop over, and it will just call that algorithm, and it will be trained. And there are some hyperparameters which you can externally modify, and this is what this map hyperparameter method is. So you can always define few of the hyperparameters like discount factors and so on, right? So once that is done, you can do the training. So now this is the most important part. So, and this is what we have explained in the presentation. So you can import this RL estimator. So if you look at this RL estimator, we have imported it from sagemaker.rl, right? So this is the RL estimator. So you can, everything for reinforcement learning are inside this class RL, in this module, and you can just import whatever you want. Okay, so now let's go back to this code, and you can define what should be the starting point. right? So you are defining this. This should be the script that it should execute, and it is based on what toolkit. So we are mentioning that it is based on RL toolkit, and it also says few of the dependencies. If you have, you can define that. If you are calling some other script or some other code inside your folder, you can always do that. And this is based on the TensorFlow, and that's why we are mentioning the framework as TensorFlow, and the instance type, number of instances, and the output, right? So all of these are general parameters that you should parse to define a training job. And this is the hyperparameter part where you can define few of the hyperparameters here, or you can define it outside this as well. Before you do the you call this fit method, because fit once you start run fit, it will start the training job. It gives you some warning that this instance name is renamed, because this is an older Sagemaker version, because it's an old notebook, and I have not updated that. But basically, in the latest Sagemaker version 2, there are a few variable names got changed, like train instant type has been renamed as instant type, right? So we just got over with the training part, because these are generally actually just an instance, right? So it doesn't have to be it can be used for training as well as for inference. So once the training is done, you can just scroll down, and you will see that this training took for almost 30 minutes. So you'll be charged only for 30 minutes. And in fact, you can go to the UI, and you can come to the training jobs, and you can see that training job. So let's say, I guess this would be, I just ran it yesterday. So this is a training job. Okay, this is, I guess, this was just a second. This one, it was for a different job. So this is the training job which got created, and if you scroll down, it will tell you all the hyperparameters that you have mentioned, RL coach, the preset, all of these, right? So what is the code for evaluation, and all of that are mentioned here. And you can check the logs. So if you click on logs, it will redirect you to the CloudWatch page, and you can see the logs here. Okay, so now going back to this, once you are done with that, what in reinforcement learning or what in Sagemaker you need to do is, often you need to do is, while the training is going on, you need to check how the model is doing, right? So what Sagemaker does is it saves the model checkpoints while the training is happening. So when we say model checkpoints, it basically stores the state dictionaries and all those weights, so that you can just use an intermediate state and see how the model is doing, right? So, and you define where it should be saved. So if you remember, here we have mentioned the output path, and it's an S3. Yeah.
So just one interruption. If you could increase the screen size, it's very small. Audience are facing difficult.
I'm sorry.
The code size. Yeah.
Okay.
Looks good. Yeah. Thank you.
Okay. Thank you. Thanks about that. Yeah. Sorry. Yeah. So you define some output path, and this is the path where the output artifacts or model checkpoints, everything gets saved, right? So you can use that, and you can visualize how the training is going on. And this is the same cell where we are just loading the model checkpoints, and we are just visualizing that. Okay, so if you just scroll down, you can see that your training reward is kind of increasing over the period of time. And this is not a very, we have not trained it for enough number of times, and it's just stimulation. But if you run it for a long period of time, you will see that the reward is going up, and it is able to learn pretty well. Because initially it might be switching off the instance, or powering off the instance randomly, right? Because this is where the exploration comes into picture, what Donnie was mentioning. And once it has done enough exploration and has collected good amount of information, it can exploit that environment, right? So now, in this part, you might see some exploitation, right? So that's about it. And once this is all done and you want to deploy that, you can always deploy using deploy method. Okay, so you can always use a deploy method on that estimator to deploy. So now we have used an instance for the training, and once the training is done, it will it will destroy that instance, right? And now you have your training model artifacts in S3. Now the next thing that you need to do is you need to deploy that, right? So once you deploy, this model will be deployed in some instance, and you can define that instance type here, right? And once you do that, you can always start doing a prediction. So this is a toy example, and that's why you can be just stimulating the observation state. And since this is we have created this script, this auto scale sim script, which has stimulation. We are giving the state as just a NumPy array because it just takes a 25-dimensional vector. So we are just giving that some random array, and we are getting some prediction what to do, right? What should be the action, whether to switch off the instance or switch on the instance, right? So that's the whole idea. But the flow is exactly like this, right? So you create the training job using the RL estimator, and then you deploy it using deploy method, right? So that's the whole point about this reinforcement learning algorithm. And it's not about reinforcement learning algorithm. Most of the Sagemaker machine learning or deep learning algorithms works in the similar fashion. You have to use the estimator object, and you can pick up any of the inbuilt algorithm, or you can deploy, or you can create your own algorithm. Okay, so that's about it. There are few links I would like to share with you. Okay, so so this is, let me just try to copy it here. Okay, we are going to share it with you on the chat, but I'm just putting it. Let's see how it works. Okay, it's quite big. I need to. Okay, so these are a few of the links which I'll just quickly paste it here. Okay, so it has. I just pasted it in the chat. I hope you get that. So these are the. I will just change this. So this is the Deep Razor League link where you can just join this Deep Razor League, and we have opened this league from tomorrow onwards, and you can join. You can build your reward function, and you can try it out of your own, and then you can submit. Right, and we will share this link. You cannot take a screenshot, but we just pinged in the chat. And then this is the GitHub repo, which the code that I was explaining on OpenAI Gym and SageMaker. And there is another link which is under AWS SageMaker examples, and there you can find lots of reinforcement learning problems which have been solved using SageMaker. Right. So that's all from my side. I'll hand it over to Sukanya.
Thank you, Suman. Thank you, Donnie. I mean, this meetup was amazing, actually, with tons of information, and certainly the Deep Razor part and reinforcement learning part. All of them are very interesting. For all the participants who are here, we have planned some contest. If you qualify as a winner of the contest, we have 10 Deep Razor AWS $100 credits to give away. Suman, would you like to walk through the contest? And I'll add you.
Yeah, sure. So let me just share my screen again. Just give me a moment.
Sure.
So if you come to Deep Razor, there is something which Donnie has explained a bit. But if you come here and the link that we have posted in the chat, if you just click on that, you'll see that community raise, and there is a community raise which is coming up in because this works in, I guess, in the PST time zone. Although I've created today in the morning, but it will get activated from tomorrow onwards. So you can you can create your once it is active, you can click on enter the race, and there you can build and train your model, and you can submit based on your preference. Whichever is the best reward function that you have written, which was the best model, then you can just submit that. And over the period of time, this would be open till December 28th. Once you join, you will see other people's rank here as well, and this is what Nico and today in the morning when he was explaining that how he secured the first position with 8 seconds lap time. So here you can see your entry time. So what we are going to do is we are going to share some reward. Based again, I'm just talking about reward, but basically we'll give you some vouchers which you can use. And thanks to Donnie, he got those vouchers for us. So we are going to share $100 of a voucher to the winners. And not only that, we are also expect you to pen down your learnings on reinforcement learning and Deep Razor, and share those blog posts to Sukanya or to Donnie or to me or to everyone for that matter, and you can share it over LinkedIn or wherever you feel like. And we will pick up whoever submitted any of those write-ups, and we will share the credit codes for them as well. All right, so feel free to share your experience and learning, right? So and we have enough number of rewards, but I'll make sure that each and every one of you get some reward based on your hard work, right? So I will strongly encourage you to do two things. One is to participate in this race, and second is come up with some literature. It can be blog or a small YouTube video, whatever it is. Just put your learning to the external world, right? So there are a lot of people do that in our community. Vivek, I know him for a long time, so he always shared a lot of things on Deep Razor and machine learning to various communities in India and across other parts of the world. So I really encourage you to do that. It would be great to learn from all of you. Right?
That's great. So post this meetup, I'll send an emailer to the user group, and you can find all the links again shared by Donnie and Suman. I'll consolidate all the links and share it across over this emailer along with the race link, so that you can participate, and we can choose winners by end of December. So thank you all. So we conclude for the day. Thank you, Suman. Thank you, Donnie, for your time. And again, it was amazing. So I'll share the recording with the audience as well. Thank you so much. Thank you, everyone, for joining us.
Thank you.
Thank you.
Everyone.
Thank you so much.
Have a good luck.
Bye.
Bye.